So this is Objective 9. We are going to learn how to name polynomials today, and we're going to be able to write polynomials in standard form. Okay. The notes, actually, the PowerPoint does not cover standard form, but we're going to look at that in our book after. So we're just going to take care of the first part with the actual PowerPoint, how to name them. Before tomorrow, we're going to start adding and subtracting and multiplying and dividing polynomials. But before you can start working with them, you got to know what in the world you're looking at. Okay, you got to understand that you're looking at a trinomial, and you got to understand what the separate terms are, and you've got to understand, what degree do you have and how we're going to write our answers. So again, this is just background information. So lots of definitions coming your way. Okay, the first thing we're going to start with, I got a little typo here. A polynomial is a monomial or the sum of monomials. What do I mean by sum of monomials? Right, a bunch of monomials being added together. Okay, so a polynomial is a monomial or the sum or a whole bunch of monomials being added together. And everybody says, well, that's great. I understand that, but what in the world is a monomial? What's the prefix mono mean? One. It's not the disease. Okay. Mono means one. So if it's a monomial, then it will have one term. If it's a binomial, bicycles have two wheels. Prefix bi means two terms. If it's a trinomial, tricycles have three wheels. So if it's a trinomial, it'll have three terms. And if it's a polynomial, it will have four or more terms. So here's what I'm here to tell you. We see one term, two term, three terms quite often. So those get special names. You follow along with me? Because we see them, they get special names. Monomial, binomial, trinomials. But we don't see 4 terms and 5 terms and 6 terms and 7 terms and 8 terms and 9 terms. We don't see those very often. So those are just called polynomials. What's the prefix poly mean? Actually, it just means many or multiple. Okay? So many terms is a polynomial. Okay? A polygon means many sides. Now, we know a whole bunch of polygons, right? And I'm just going to go back to elementary school for a minute. Polygons is the topic of all the sided figures, right? But we know all kinds, and so many sides, polygon, okay? And so we know many types of polygons, okay? We know octagons. We know hexagons. We know heptagons, we know nonagons, we know decagons, right? But all of those, is an octagon a polygon? Polygon is like the topic, but when they have specifically 8 sides, it gets a special name, right? Because we see those often. We see them every day. We see an octagon every day. Where at? Stop sign, right? We see those every day, so it gets a special name. So yes, an octagon is a polygon, but because we see it a lot, it gets a special name. It's an octagon. Okay, do we see decagons? We see occasionally, so they get special names. 12-sided figures are called dodecagons. Okay, what about an 11-sided figure? Do you see those often? No, so does it get a special name? You just call it an 11-sided figure. Does that make sense? What's a 13-sided figure called? A 13-sided figure. You don't see them very often, so they don't get special names. You follow? What's a 14-sided figure called? A 14-sided figure. You with me? So if you see it a lot, it gets special names. But if not, it just gets one of those names. So here's what I'm going to tell you. You see these a lot. All of these are polynomials. Polynomial is like the topic. A monomial is a polynomial. But because you see one terms quite often, you can get a little more specific and specifically call them monomials. Okay? You see binomials a lot. Okay? A binomial is a polynomial. Do you understand that? A binomial is a polynomial, but because it has two terms, you can get a little more specific with it. Okay? Same thing with trinomial. You don't see 4, 5, 6, 7, 8 terms a lot, so they don't have special names. You just call them polynomials. Does that make sense? Okay? So all of these are polynomials, but if they're 1, 2, or 3 terms, they get special names. Okay? So everybody says, well, great, I understand a monomial has 1 term, and a binomial has 2 terms, and a trinomial has 3 terms. But what's a term? A term can be one of 3 things. A term can be a number, just a plain old number. Ready? Give me a plain old number. Ready, set, go. 1, 2, 6, 4. Only just positives? -2. 32. -14. Just plain old numbers. Those are terms. Okay? They can be plain old numbers. Okay? Or it can be a variable. Okay? Give me just a variable by itself. Ready, set, go. Y, B, C, S. Very good. Plain old variables. Okay? Or it can be the product of a number and a variable. Okay? It can be the product of a number and variable. What do I mean by product? Multiplied. So take a number and a variable and multiply them. And give me an example. Ready? A number and a variable and multiply them. 5x. Very good. 2n. 3z. 6b. 4n. 5s. 5s. 10a. Sorry to put you on the spot. Okay. But that does make sense. Who do I know very well that I can use? Okay. Can I use you for example? It's a little awkward. Okay. Have y'all ever seen or heard of the movie Stuck on You? No. It's about conjoined twins, and it's really hilarious. I hadn't even seen it all the way through, but it's got those funny actors. I think some of them play on, like, what's the skating movie, Blades of Glory, or Dumb and Dumber. You know what I mean? They're like funny, silly, crazy movies, whatever. But it's about 2 guys that are conjoined twins, and so they're like stuck together. Sorry, I don't mean to make you feel uncomfortable, but they're stuck together. And if they want to go use the bathroom, they have to go together, right? And if they want to go, I'm not talking about us. He's like, if they want to, go to sleep, they have to go together. If they want to go eat, they have to go together. If we want to go to the tissue box, we have to go together to the tissue box. You with me? They're stuck together. So that's what I want you to think of. First block said something about, what are the dinosaurs that are conjoined? It's some kid show. One's like a purple-headed and dragon tails. Are they conjoined? That's what first block said. Dragon tails, but they're like Miss Corns. We don't know what you're talking about. Think dragon tails, and I'm like, okay. Are they conjoined? Yes. Okay. So somebody knows. But whatever I'm talking about. That's what I want you to think about. A product. They are stuck together. A number and a variable. They're one term. You got that? A number and a variable are one term. Does that make sense? Okay, they're stuck together. Woo! So remember that. So let's look at some examples. My question to you is, how many terms do you see? Austin. He sees 3. Anybody beg to differ with him? We see 2. I have some that see 2. I have 3. How about a show of hands? 2 or 3? 2, 3. What do you see? So what's one term you see, Tanner? 4a. Is that a number, a variable, or the product? That's product of a number and variable, right? Okay. What else do we see? And be a little more specific. How about negative 3b? Does that make sense? That negative goes with 3b. Is that a number, a variable, or the product? That's product. Do we see anything else? Positive 7. Is that a number, a variable, or a product? That's a number. So do those classify as terms? So how many do we see? 3. Okay. So what will we call this guy? This is a trinomial because it has 3 terms. Okay. Trinomials are separated. How do you know? So when they're one term, they're stuck together. How do you know when they're separate? Like, how do you know once you start? Well, I started at the 4a. How did I know when I got to a new term? What did I see? A sign, a plus sign. Terms are separated by plus and minuses. Does that make sense? So what you could do, sometimes if you have trouble seeing the terms, I do want you to understand that the negative does go with the 3b and the positive does go with it, but you could outline your signs and you know that everything on either side of it is a term. 1, 2, 3. Does that make sense? So if you like that better, you can do that. Okay? All right. How many terms do we see? 2. Very good. What's one term? 5x. What's another term? 2. This is a product. This is a number. So we would call this guy a binomial. 2 terms. How many terms do we have? 4 terms. Very good. What's one of them? Negative 8g. Negative 9g. Negative j. Oh yeah, negative 9h, sorry. Negative j. And positive 9. Again, product, product. What would you call that? I hear variable. Could you call this guy a product? So either or. I see variable, I see product. Either way, it's a term. Does that make sense? And this is just a number by itself. So I agree. Product, product, whichever one you want to say, product or variable, and then a number. So what will we call it? A polynomial. 4 terms. Again, 4, 5, 6, 7, 8 terms. They don't have special names, so you just call those polynomials. Okay. How about this one? How many terms? 1, so what would you call it? It is a variable, but because it has 1 term, you would call it a monomial. Any questions on that? Okay, so here's what I'm going to tell you. You've learned part 1. When we name polynomials, they will have first names and last names. Okay, you've learned the last name. It's based on its terms. Okay, if it has 1 term, monomial, 2 terms, binomial, 3 terms, trinomial, 4 terms, polynomial. But it'll have a first name and a last name, kind of like Austin Rakes, kind of like Jordan Reynolds. You with me? Kind of like Lake and Roar. Okay, first name and a last name. Does that make sense? So these are the last names. Let's talk about the first names. First names are based on their degree. Okay, we're first going to look at the degree of just an individual term of a monomial. Everybody agree that's just 1 term? And then we're going to talk about what happens when you have a whole bunch of terms. What's the degree? So we're going to talk about 2 different degrees. Degrees of just an individual term itself, and then degrees of the whole thing when you have a whole bunch of them. Okay, so the degree of a monomial is the sum of the exponents of the variables. So write that down and then we'll talk about what that means. So the degree of the monomial, tell me what we're going to do here. It says the sum, so we are going to add the exponents of the variables. Tell me something. Do numbers have exponents? Yes. What are they? Like a 3 would have a 1. So I agree they do have exponents, but this is not what this is talking about. This is talking about only the sum. We're going to add the exponents of just the variables to figure out the degree. Okay, so we're not going to include the exponents of the numbers at this time. Okay, so would you agree, for example, 5, is that a monomial? Why? There ain't no signs and they are stuck together. You with me? They are stuck together. That is all one giant term. It is stuck together. Okay? Now, if you had a big plus or minus between some of it, it'd be more than one term. But because it's all stuck together, it's one term. Okay? So, my question is, to figure out the degree, it says we are going to add the exponents of the variables. What are the exponents of the variable? 2 and 1. And again, I agree that this guy does have a 1, but you're only looking at the variable. So what's its degree? 3. Very good. How about example 6? What's the degree? 5. Very good. This has a 1, this has a 1, and 3. And if you add the exponents of the variables, you get 5. I thought we were supposed to add them. There ain't nothing else to add. Okay, so if it's just that one variable, then it's just that exponent. It has a degree of 3. Okay? Probably not. Okay, how about this one? Doesn't that have a 1 with it? Doesn't this have a 1 with it? It's not a variable, remember? Only we're talking about the variables. When there are no variables, the degree is 0. Okay, so any questions on how to figure out the degree if you're just looking at an individual term? Now what we're going to do is we're going to look at the degree of a polynomial. So when you have a whole bunch of terms, what's the degree? So what is this telling us? The degree of a polynomial is the greatest degree of any term in the polynomials. So that means what are we going to do? When we have a whole bunch of them, we're going to take the biggest. My mama told me to pick the biggest one, and you are it. Does that make sense? That's what I say. My mama told me to pick the biggest. So what we're going to do first is we're going to look at each individual term. So look at the first term. How many terms does this guy have? 4. So we call it a polynomial. Very good. Okay, so let's look at the first term and tell me what's the degree? 3. Very good. Here's where you add them. Some people get confused, like when do I add them and when do I pick the biggest? So when you're looking at just one term and it's got more than one variable, here's where you add them. Okay, so what's the degree here? 2. What's the degree here? What's the degree here? 0. Now, how do I figure out the degree of the whole thing? My mama told me to pick the biggest, and it is 3. So this polynomial has a degree of 3. You pick the biggest. Okay? Do you see some people try to do what with all these? They try to add them up, but you only add them when you're looking at each individual term. Okay? What do you think the degree is for this one? Everybody agree with 2? It has 3 terms. What's the degree of the first one? 2. What's the degree of the second one? 1. What's the degree of the third one? 0. And how do I know the degree of the whole thing? My mama told me to pick the biggest, which is 2. Okay? Just FYI, on today's work, you won't have to show that much work, but what's one thing that I'm doing to show work? Writing the degree above it. That might be one way to show a little bit of work, but you're probably going to be able to do all your work on the one page. Okay? Can someone tell me what I'm looking at with example 11? A trinomial, everybody agree? 3 terms? Okay, so what's the degree of the first one? 4. What's the degree of the second one? 3. What's the degree of the third one? 2. And the degree of the whole thing, my mama told me to pick the, which is 4. Question, Harvey. Not all of them. And so here's where we get into standard form, okay? Actually, the ones in your worksheet are not written in standard form, but standard form is how you properly write your answers. So when we start adding them and subtracting them and multiplying them and dividing them tomorrow, wouldn't you be confused? Like, what if you on your paper had this term up here, and this term right here, and this term right here, and then I call out the answer, and I say the answer to number 4 is 5x cubed y minus 4x squared y minus 2xy, and yours was all jumbled up. Wouldn't you be confused? So what we're going to get to in a minute is called standard form, and it's basically you write it in descending order, starting with your highest degree, working your way down to your lowest. And so we're going to talk about that, and we're going to look at some examples in the book. All answers must be written in standard form starting tomorrow. You with me? Once we start adding them and subtracting them and multiplying them and dividing them, when we write our answers, we want them in descending order, starting with the highest degree down to the lowest degree. Okay, that's standard form. So not always will you see that on your worksheet today. I had a choice. Put all questions in standard form or mix them up, and I chose to mix them up. That way you could look at each term, you with me? But generally, if it's in standard form, the highest one is the first one. Greatest to least. Greatest degree down to least degree. We're going to, like I said, we're going to look at some examples in the book in a minute. Okay, so now we know how to figure out the degree, right? So everybody says, well, what do you mean, how are we going to name it? So here are your names, okay? This is my favorite part of the PowerPoint. You ready for this? Don't miss it. Anybody get excited like when you're messing with the computer and you get things to fly in? And okay, maybe it's just me. All right, here's your names. So if it has a degree of 0, we will call it constant. If it has a degree of 1, its first name will be linear. If it has a degree of 2, it will be called quadratic. If it has a degree of 3, it will be called cubic. And then, check this out, 4th degree, 5th degree, what do you think 6th degree would be? 6th degree, 7th degree. Why don't they get special names? Because we do not see them often. These ones up here we see quite often, so they get special names. Okay, I'll give you a second to write that down, and then we're going to talk about it. Do you recognize any of those names? Quadratic and cubic? Have you seen linear? Have you heard linear before? Let me explain to you. When you were in elementary school, you solved linear equations. Like if you had an equation that looked like so, you called that a linear equation. You want to know why you called it? You didn't realize this at the time. Has everybody's heard of linear before? What's the degree of this term? 1. What's the degree of this? 0. What's the degree of this guy? 0, because remember it's the exponent of the variable. These don't have variables, so it's 0. Okay. And what's the degree of the whole thing? My mama told me to pick the biggest, so what's the degree of it? 1, which is why you call it linear. Makes sense now? Yes? No? Maybe so? Oops. So these are the first names. You already know the second names, but here they are. I'll put them up one more time. Okay? If you want to, if you don't want to, I mean, if you know them, if you got it. We've talked about this. If you want them all in one chart. Okay? The last names are based on its terms, and if it has 1 term, it's a monomial. 2 terms, it's a binomial. 3 terms, it's a trinomial. 4, 5, 6, 7, 8 is all polynomials. Okay? So we're going to put these together. So you may look at something and it may be a constant monomial, or you might have a cubic binomial, or you might have a quadratic trinomial. Does that make sense? So it'll have a first name and a last name based on its degree and based on its number of terms. So we're almost finished. We just got to put it all together. Anybody still writing? Okay. I'll give you another minute. Okay. Let's put it all together. So I'm going to draw 2 blanks. Why do I draw 2 blanks? Yeah, the first name is based on its degree, and the second one is its number of terms. Okay, does it matter which one you find first? No, I like to find, for some reason, I like to find the number of terms first. I like to look at it and say, how many terms does it have? 3, so what would its last name be? Trinomial. Any questions? It has 3 terms, so it's a trinomial. Now let's look at its degree. Remember, what's the degree of the first term? 2, what's the degree of the second term? 1, what's the degree of the third term? My mama told me to pick the biggest, which is, so what would we call it? Quadratic. This is a quadratic trinomial. Any questions on that? Again, I would make a point to draw 2 blanks, because that will help you to remember to give it 2 names. Okay, we're not going to have any shares or any Barbies or any, what are some more one-name people? I think of a one-name person. Madonna is a one-name person. We're going to be normal, and we're going to have a first name and a last name. Does that make sense? Okay, so who would like to give me one of the names, or both, of this one? Eeny, meeny, miny, mo. Let's go Austin first. Got linear. Everybody agree? The highest degree is 1. The first one is a 1. The second one is a 0. My mama told me to pick the biggest. And the last name is? It's a binomial because it has 2 terms. Harvey, I'm going to get you next. Any questions? That is a linear binomial. Okay. You try these 2, and then we'll talk about them. Harvey gets the first one. Lucy gets the second one. Okay. Harvey, what do you think about example 14? One or both of the names, either one. He thinks cubic polynomial. Agree or disagree? Agree. This has a degree of 3. This has a degree of 2. This has a degree of 1. This has a degree of 0. And everybody says, Miss Quartz, I thought you had to add them. That's only when what? Why aren't we adding these guys? We don't. Each term only has one variable. When do we add them? When each term has more than one variable, that's when you add them, which is not very often. Most of the time, it's just that variable. Okay, so I do agree the highest one is 3, so we would call it cubic. How many terms? 4, so it is a polynomial. Very good. All right, Lucy. A linear monomial. I do agree it has one term. What's the degree of it? Does it have any variables? Remember, the degree is the exponent of the variable. So when there are no variables, it's a constant. This has a degree of 0, so this is called a constant. And I do agree that that guy has a 1, but we don't look at the numbers. We only look at the variables. So we call this a constant monomial. Any questions? Okay. So we're going to try some practice. I know this says practice worksheet. We're going to get to the worksheet in just a minute. But before we get there, I would like for you in your books to turn to page 426. And we're going to look at 7 through 14.